What's up, YouTube? It's Trilla Manila. It is day 42 on the Road to Code and 100 Days of Code challenge. So today we finished up with object-oriented programming in JavaScript section, a free code camp. So in light of that, what I'm going to do is read a blog post about it, just explaining it more in depth, basically giving you guys just sharing with you guys what I learned. But yeah, and also in light of Manny Pacquiao's win, rocking the Team Philippines shirt. I do have a Pacquiao shirt, so somewhere in there. But anyways, let's just get right into it. Alright, this is one of the intros right here. Why do you need to know this? Have you picked JavaScript to be your first programming language? Do you want to be a hotshot developer who works on giant enterprise systems spanning 100,000 lines of code or more? Unless you learn to embrace object-oriented programming fully, you'll be well and truly lost. Alright, different mindsets. In football, you can play from a safe defense. You can play with... Alright, hold up. We're just getting right into it. The object-oriented paradigm. From the OOP perspective, which stands for object-oriented paradigm, an application is a collection of objects that communicate with each other. We base these objects on things in the real world like products and inventory or employee records. Objects contain data and perform some logic based on their data. As a result, OOP code is very easy to understand. What is not so easy is deciding how to break an application into these small objects in the first place. If you were like me, when I first started this first time, you would have no clue what this actually means. It all sounds very abstract. Feeling that way is absolutely fine. It is more important that you have heard this idea, remember it, and try to apply OOP in your code. Over time, you'll gain experience, a line of your code with this theoretical concept. Lesson: OOP based on real-world object lets anyone read your code and understand what's going on. Object as centerpiece. A simple example will help you see how JavaScript implements the fundamental principles of OOP. Consider a shopping use case in which you put products into the basket and then calculate the total price you must pay. If you take your JavaScript knowledge and code the use case without OOP, it would look like this. It shows example, const spread, name, bread, price, 1. But yeah, it's just showing examples of different objects in groceries and code. I should just share the screen, but maybe next time. The OOP perspective makes writing better code easier because we think of objects as we would encounter them in the real world. As our use case contains a basket of products, we already have two kinds of objects, the basket object and the product objects. The OOP version of the shopping use case could be written like this. Another example again. As you can see in the first line, we create a new object by using the keyword new, followed by the name of what is called a class described below. This returns an object that we can store to a variable bread. We repeat that for the variable water and take a similar path to create a variable basket. After you've added these products to your basket, you finally print out all the total amount you need to pay. The difference between the two code snippets is obvious. The OOP version almost reads like an English sentence, and you can easily tell what's going on. Lesson: an object modeled on the real world things consists of data and functions. Alright. Class as template. We use classes in OOP as templates for creating objects. An object is an instance of a class, and instantation is the creation of an object based on a class. The code is defined in a class but can't execute unless it is a live object. You can look at classes like the blueprints of a car. They define the car's properties like torque and horsepower, internal functions such as air to fuel ratios, and publicly accessible methods like the ignition. It is only when a factory instantates the car, however, that you can turn a key and drive. In our use case, we can use a product class to instantiate two objects bread and water, of course, and these objects need code, which you can provide with the classes. It goes like this. Another example, and I'm just look at it. Alright, a class in our JavaScript looks like a function, but you can use it differently. The name of the function in the class's name and is capitalized. Since it doesn't return anything, we don't call the function in the usual way, like const basket equals product parentheses bread comma 1. Instead, we add the keyword new, like constant basket equal new product. So the only thing different was adding new. The code inside the function is a constructor. This code executes each time an object is instantiated. Product has the parameters name and price. Each new object stores these values inside of it. Furthermore, we can define functions that the object will provide. We define these functions by prepending the dis keyword, which makes them accessible from the outside. Notice that the functions have full access to the properties. Class basket doesn't require any arguments to create a new object. Instantiating a new basket object simply generates an empty list of products that the program can fill afterwards. Lesson: a class is a template for generating objects during runtime. Alright, and now next section is about encapsulation. You may encounter another version of how to declare a class, which is a function, product name, parentheses, name, comma, price, parentheses, curly braces, this.name equal name, semicolon, this.price equal price, semicolon. Mind the assignment of the properties to the variable this. At first sight, it seems to be a better version because it doesn't require the getter, getName, and getPrice methods anymore, and therefore is shorter. Unfortunately, you have now given full access to the properties from the outside, so everybody can access and modify it. Alright, like that. This is something you don't want as it makes the application more difficult to maintain. What would happen if you added validation code to prevent, for example, price less than 0? Any code that accesses the price property directly would bypass the validation. This could introduce errors that would be difficult to trace. Code that uses objects getter methods, on the other hand, is guaranteed to go through the object's price validation. Objects should have exclusive control over their data. In other words, the objects encapsulate their data and prevent other objects from accessing the data directly. The only way to access the data is indirect via the functions written into the objects. Data and processing, aka logic, belong together. This is especially true when it comes to larger applications where it is very important that processing data is restricted to specifically defined places. Done right, OOP produces modularity by design, the holy grail in software development. It keeps away the feared spaghetti code where everything is tightly coupled and you don't know what happens when you change a small piece of code. In our case, objects of class product don't let you change the price or the name after the initialization. The instances of product are read-only. Lesson: encapsulation prevents access to data except through the object's functions. Alright, that's pretty important. I like that. Inheritance. Inheritance lets you create a new class by extending an existing class with additional properties and functions. The new class inherits all of the features of its parent, avoiding the creation of new code from scratch. Furthermore, any changes made to the parent class will automatically be available to the child class. This makes updates much easier. Let's say we have a new class called book that has a name, a price, and an author. With inheritance, you can say that a book is the same as a product, but with additional author property, we say that the product is a superclass of book and book is a subclass of product. Alright. Note the additional product.call along with this as the first argument. Please be aware, although book provides the getter methods, it still doesn't have direct access to properties name and price. Book must call that data from product class. You can now add a book object to the basket without any issues. Basket expects an object of type product. Since book inherits from product through book, it is also a product. Lesson: subclasses can inherit properties and functions from superclasses while adding properties and functions of their own. JavaScript and OOP. You can find 3 different programming paradigms used to create JavaScript applications. They are prototype-based programming, object-oriented programming, and functional-oriented programming. The reason for this lies in JavaScript's history. Originally, it was a prototype-based. JavaScript was not intended as a language for larger applications. Against the plan of its founder, developers increasingly used JavaScript for bigger applications. OOP was grafted on top of the original prototype-based technique. The prototype-based approach is shown below. It is seen as a classical and default way to construct classes. Unfortunately, it does not support encapsulation. Alright, so these are different methodologies. Okay, I see. And they're all 3 of these methodologies are part of the Free Code Camp courses. So that's interesting. And they're going in the order that was listed, with the prototype-based programming first. Even though JavaScript support for OOP is not at the same level as other languages like Java, it is still evolving. The release of version ES6 added a dedicated class keyword we can use. Internally, it serves the same purpose as a prototype property, but it reduces the size of the code. However, ES6 classes still lack private properties, which is why I stuck to the old way. For the sake of completeness, this is how we would write the product basket and book with ES6 classes, and also with the prototype, classical, and default approach. Please note that these versions don't provide encapsulation. Alright, so I'm just looking at the code here. Alright, continuing on from the example, it's a pretty long piece of code actually. Lesson: OOP was added to JavaScript later in its development. Okay. Summary: as a new programmer learning JavaScript, it will take time to appreciate object-oriented programming fully. The important things to understand at this early stage are the principles of the OOP paradigm is based on and the benefits they provide. Objects modeled on real-world things are the centerpiece of any OOP-based application. Encapsulation protects data from uncontrolled access. Objects have functions that operate on the data. On the data the objects contain, classes are the templates used to instantiate objects. Inheritance is a powerful tool for avoiding redundancy. OOP is more verbose, but easier to read than other coding paradigms. Since OOP came later in JavaScript's development, you may come across older code that uses prototype or functional programming techniques. Alright, and that was the end of that blog there. Going into object-oriented programming, that was a good read. But yeah, that pretty much wraps up today, day 42. We are almost done with the JavaScript portion in the Free Code Camp. We only got functional programming and intermediate algorithm scripting, and then we have the JavaScript projects after that. So it's just 3 more parts, and we're finally done with JavaScript. And once we know the libraries like Redux, React, then pretty qualified for a front-end job. I mean, you're not gonna know everything to the T, you know what I mean, like memorizing everything, because it's so much. But I definitely want to be at a good level, that's for sure. Definitely reaching front-end developer job is the goal for this year, definitely. And I think it's definitely attainable, and I think it's definitely attainable for anybody watching this as well. We are still in January, and we still have the whole year ahead of us. So as always, just like, comment, subscribe, follow my blog at trillamanila.com, Twitter at trillamanila as well, and have a good day. Trillamanila!